Hi everyone and welcome back to my flight mechanics class. So today we're going to be covering the lateral directional static stability, and this is essentially going to be the same as the longitudinal static stability but applied to the rolling moment, yawing moment, and aerodynamic side force. So before diving into the specifics, I'd like to cover some conventions and some basics. So when an aircraft needs to make a turn, it is very likely that it is going to rely on its ailerons. And the way that works is that on the end of one wing, you're going to have one aileron which is going to go down, and the other aileron on the other wing which is going to go up. And what this does is that it creates differential lift, and that in turn creates a bank. So the convention is that trailing edge down is a positive deflection, whereas trailing edge up is a negative deflection. For the rudder, which is the main control surface to create yaw, the convention is that trailing edge left is a positive deflection, whereas trailing edge right is a negative deflection. So when you have a side slip, if the side slip is coming from the left, it is a negative side slip. If it is coming from the right, it is a positive side slip. So let's start with the aerodynamic side force. So the method here is pretty standard. We're going to express it in terms of its coefficients, and then we're going to expand the coefficient, and finally we're going to determine which sign each coefficient should have. So we can see here that the side force coefficient is dependent on beta, the side slip angle, delta A, the aileron deflection, and delta R, the rudder deflection. So in this case, because we're talking about force derivatives, what we want to know is what signs these coefficients usually have for a standard aircraft. If we were to be talking about moment derivatives, we would want to know what signs these coefficients should have for static stability to exist. So Cy beta is essentially how much of a change in the side force coefficient you're going to have for a given change in beta, and that is usually negative. So that means that for a positive beta, or coming from the right, you're going to have a negative side force. And for a negative beta, or coming from the left, you're going to have a positive side force. So Cy delta A is how much of a change in the side force coefficient you're going to have for a given change in the aileron deflection. And that is actually negligible because ailerons don't produce that much of a side force. The only case where this would not be true is in this case. So for a given fighter jet, sometimes the horizontal stabilizer is used to create a roll, and that is achieved by having a differential deflection of the horizontal stabilizer, and in this case, this would create differential pressure on the vertical tail, which in turn creates a side force. So that would be the only case where this is not negligible. Cy delta R is how much of a change in the side force coefficient you're going to have for a given change in the rudder deflection, and that is usually positive. And that means that for a positive rudder deflection or trailing edge left, this is going to create a positive side force. And on the other hand, if you're going to have a negative rudder deflection, you're going to have a negative side force. Alright, this is it for today. Thank you very much. See you next time.